Lesson 2. The Buoyant Force. Reading Guide. Key Concepts. Essential Questions. How are pressure and the buoyant force related? How does Archimedes' principle describe the buoyant force? What makes an object sink or float in a liquid? Vocabulary. Buoyant force. Archimedes' principle. Inquiry. Why doesn't it sink? This boat is overloaded, yet it still floats. What forces are on a boat sitting in water? What forces affect whether it floats or sinks? What is a buoyant force? Have you ever floated on a raft, like the person in Figure 6? What forces are acting on this person and his raft? The gravitational force pulls them down. Recall that the gravitational force on an object is the object's weight. The weight of the person and his raft includes the weight of the column of air above them. Why don't they sink? The total weight of the raft, the person, and the air is balanced by another upward force. A buoyant force is an upward force applied by a fluid on an object in the fluid. The buoyant force on the raft is equal to the total weight of the raft, so the raft floats. Buoyant forces in liquids. You might have noticed that you can lift someone in water who you could not lift when you are both out of water. This is because of a buoyant force. A buoyant force acts on any object in a liquid. This includes floating objects such as rafts, ships, and bath toys. It also includes submerged objects such as rocks at the bottom of a lake. Buoyant forces in air. Objects in a gas also experience a buoyant force. For example, the buoyant force from air keeps a helium balloon up even though a gravitational force pulls downward. An object does not need to be floating in air for a buoyant force to act on it. In fact, a buoyant force from air is acting on you right now. However, the buoyant force acting on you is less than the gravitational force acting on you. Therefore, you do not float. Buoyant force and pressure. How does a fluid, such as water, exert an upward force on any object in the fluid? You read in Lesson 1 that a fluid applies pressure perpendicular to all sides of an object within it. Therefore, the forces from water pressure on the divers in Figure 7 are in the horizontal and vertical directions. The horizontal forces on the sides of each diver are equal, but the vertical forces on the top and the bottom of each diver are not equal. Recall that pressure increases with depth. The pressure at the bottom of each diver is greater than the pressure at the top of each diver. This is illustrated in Figure 7 by the differences in length of the purple arrows. The dark purple arrow represents the pressure pushing up on each diver. The light purple arrow represents the pressure pushing down on each diver. Notice that the arrows are longer on the diver on the right. That is because this diver is deeper than the other diver. The pressure on both the top and the bottom of this diver is greater. The difference between the upward force from pressure and the downward force from pressure on each diver is the buoyant force on each diver. The buoyant force is represented by the orange arrows in Figure 7. The buoyant force on an object is always in an upward direction because the pressure is always greater at an object's bottom. Key concept check. How is pressure related to the buoyant force? Buoyant force and depth. Does the buoyant force on a diver change as she dives deeper? Except with extreme changes of depth, the buoyant force does not significantly change. This is because the pressure of the water above the diver and the pressure below the diver increase by about the same amount as the diver goes deeper. The depth of an object submerged in a fluid has little effect on the buoyant force. Archimedes Principle. There is another way to think about the buoyant force. What happens to each object in Figure 8 as it is pushed underwater? As each object is submerged in a large beaker, some water spills out, or is displaced, into a smaller beaker. Notice that the balloon displaces more water than the tennis ball or the billiard ball does. The volume of water displaced by the balloon is equal to the volume of the balloon. Similarly, the volume of water displaced by the tennis and the billiard ball is equal to the volume of each ball. Which small beaker do you think weighs the most? The beaker on the left does, because it has the most water in it. According to Archimedes' principle, the weight of the fluid that an object displaces is equal to the buoyant force acting on the object. Because the balloon displaces more water than the billiard ball or the tennis ball does, a greater buoyant force acts on it. Key concept check. What is the buoyant force on you if you displace 400 newtons of water as you dive underwater? Recall the image of the divers on the previous page. The buoyant force on each diver does not change as the divers go deeper, because the volume of each diver does not change. Each displaces the same amount of water at any depth. Sinking and floating. Now look at the tennis ball and the billiard ball in Figure 9. Both have the same volume, but if you set each on the surface of water and let go, one floats and one sinks. Buoyant force and weight. If you set a tennis ball on the surface of water, it displaces water. With only a little bit of the tennis ball submerged, the tennis ball stops displacing water and floats. Why is this? When the weight of the water displaced by an object equals the weight of the object floats. So, the weight of the water displaced by the tennis ball, or the buoyant force, equals the weight of the tennis ball. The same is true for the leaf in Figure 9. However, when you set a billiard ball on the surface of water, it sinks. Even after the billiard ball is completely submerged and has displaced the maximum volume of water that it can, it still weighs more than the water it displaces. When an object's weight is greater than the buoyant force, the object sinks. The buoyant force on the billiard ball is greater than the buoyant force on the tennis ball, because the billiard ball is completely submerged. The water displaced by the sunken billiard ball weighs more than the water displaced by the floating tennis ball. Buoyant force and density. Because the billiard ball sinks, you know it weighs more than the water it displaces. Therefore, the billiard ball has more mass per volume, or a greater density, than water. If an object is more dense than the fluid in which it is placed, then the buoyant force on that object will be less than the object's weight, and the object will sink. Metal boats. Aluminum has more than twice the density of water. So, how does the aluminum boat in the left part of Figure 10 stay afloat? The boats in Figure 10 are the same size and made from the same material. The boat on the left is filled with air. The weight of the water displaced equals the weight of the boat plus the air inside. Therefore, the boat floats. The boat on the right is filled with water. In order for this boat to float, the buoyant force would need to equal the weight of the boat plus the water inside. However, the total weight of the boat and the water inside is greater than the water displaced by the boat, or the buoyant force. So, the boat sinks. You can also think of this in terms of density. The density of the boat and air on the left is less than the density of water, so the boat floats. However, the density of the boat and water on the right is greater than the density of water. It sinks. The buoyant force is still greater on the boat on the right because it displaces more water than the boat on the left. Key concept check. If an object weighing 14 newtons experiences a 12 Newton buoyant force, will it sink or float? Balloons. Why does a helium balloon rise? Helium is less dense than either oxygen or nitrogen in the air. Therefore, the buoyant force acting on a balloon filled with helium is greater than the weight of the balloon, as illustrated in the top of Figure 11. The buoyant force pushes the balloon upward. After a day or two, a helium balloon begins to shrink. Helium atoms are so small that they pass between particles that make up the balloon. As the volume of the balloon decreases, the density of the balloon increases. Eventually, the balloon's density is greater than the air's density. The buoyant force on the balloon is less than the balloon's weight, and the balloon falls to the ground. Balloons. Why does a helium balloon rise?